Welcome to a new deep dive. Today, we're heading way back, late Cretaceous Asia,
That's right, Mongolia, specifically.
and we're exploring a member of the Tyrannosaur family that, well, for a long time it was a bit mysterious, Alioramus.
Yeah, it definitely held on to some secrets. We'll be digging into the fossil evidence, starting with that initial discovery by Sergei Kirsanov, the Soviet paleontologist, back in '76.
Right.
And then, of course, the much more complete picture we got with the second species, found by Stephen Broussard and his team in 2009.
And we'll also use, the very scientific studies that help us place it, understand this sort of different branch of Tyrannosaur.
Exactly.
So our mission today is really to get under the skin of Alioramus. What makes it different from, say, the heavyweights like T-Rex or Tarbosaurus?
Uh-huh.
We'll look at its physical features, its family tree, maybe what it ate, and, what it tells us about that ancient Mongolian environment.
Okay.
So the name itself, Alioramus, that tells a story, doesn't it?
It does. Different branch. It hints right away that its connections weren't clear at first.
And the species name, remotus, meaning removed.
Yeah, like it was seen as separate, an outlier even then.
So Alioramus remotus, discovered early 70s, described in 76, Nemeg Formation, Mongolia.
Right. And described from, well, not a lot.
Right.
Partial skull, 3-foot bones, that was it.
Hmm.
But even then, that different branch idea started to form.
Then fast forward to 2009, Alioramus altai, also Nemeg Formation, but a different spot, Sagankushu.
And this was, yeah, a real game changer. A much, much more complete skeleton. Finally, a better look.
And interestingly, the kinds of fossils found at these two spots, they might suggest slightly different time periods.
That's a possibility, yeah. The faunal differences hint at that.
Yeah.
The Altai find gave us, like, almost a complete skull,
Wow.
which was huge compared to what we had. Plus bits of the spine, the hip, hind limbs, the name Altai that refers to the nearby Altai Mountains.
Got it. So comparing it to other Tyrannosaurs,
Yeah.
the size is the first thing, right? It's smaller.
Definitely smaller than the big ones. Early estimates for Aeromotus were maybe 5 to 6 meters long.
And now it's thought maybe 5.5 for remotus, 5 for altai, somewhere around there.
Yeah, roughly.
Yeah.
And significantly lighter than an adult T-Rex or Tarbosaurus.
But, and this is key, these known specimens are probably young ones, right? Juveniles or subadults.
Exactly. So they're full adult size. Still a bit of a question mark.
Which already suggests maybe they weren't doing the exact same thing ecologically as the giants.
Absolutely. And even in these younger animals, you see some really unique things, like those crests on the snout.
Oh yeah, the bony crests, 5 of them.
5 of them running along the top. And not just little bumps, over a centimeter tall.
What were they for? Display?
Could be display, species recognition.
Yeah.
We're still debating that. But visually, yeah, very striking.
Definitely gives it a unique profile. And then the teeth. This is wild.
Ah, yeah. The teeth are something else.
It had more teeth than any other Tyrannosaur.
That's right. 76, maybe 78 teeth.
Yeah. Wow. So slender build, lots of teeth. This doesn't sound like a bone crusher.
No, probably not. It really paints a picture of a tyrannosaur maybe going after different kinds of prey, using a different strategy. It's a great example of, diversification within a family.
And the skull shape itself.
Long and low, which is interesting because that's kind of reminiscent of more primitive tyrannosaurs,
All right, the earlier ones.
or even what you see in young T-Rex or Tarbosaurus. And the lower jaw was also long and quite slender.
But it did have that locking mechanism in the lower jaw, like Tarbosaurus.
It did, yes, between the dentary and angular bones. Reduced flexibility there.
Okay, so back when A. remotus was first found, with just those fragments, classifying it must have been tricky.
Oh, very. There was debate. Did it even belong in the main Tyrannosauridae family? Some thought maybe its unique features meant it was more basal, further down the tree.
But then A. altai came along.
Right. The more complete skeleton really solidified its place within Tyrannosauridae. Early on, it was put in the Tyrannosauridae subfamily.
So alongside T-Rex, Tarbosaurus, Desplotosaurus.
Yeah, that was the initial thinking. Still a different branch, but definitely on the main Tyrannosaur tree.
Then, 2014, another long-snouted guy shows up. Cancosaurus. Pinocchio Rex.
Yeah, that discovery led to this new group or tribe being formally named Alioramus.
Which includes Alioramus and Cancosaur.
Correct. And where exactly Alioramus fits? Well, that's still being worked out. Some studies put them close to Tyrannosaurus.
Uh-huh.
Others suggest they might be a sister group to all other Tyrannosauridae. So the resolution isn't quite perfect yet.
It's fascinating, though, how Alioramus shares some things with Tarbosaurus, like that jaw lock.
Yeah, and also the lack of that specific connection, that prong between the nasal and lacrimal bones in the skull. Most tyrannosaurids have it, but not Alioramus, and interestingly, not adult Dasboltosaurus.
Hmm.
These similarities might point towards a distinct Asian group of tyrannosaurs. And, some Tarbosaurus skulls actually have these low bumps on their nasal bones.
Really like faint versions of the Alioramus crests.
Kind of, yeah. Maybe hinting at a shared ancestry expressed differently.
And even though the known Alioramus seem young, that high tooth count in Remotus was a big clue. It was distinct,
Yeah,
right?
definitely. Especially because we know young Tarbosaurus have the same tooth count as the adults. So the difference in Alioramus was significant.
Okay, so putting it all together, how did Alioramus likely live? That slender build, the less robust skull.
It strongly suggests it wasn't using that classic puncture pull, bone-crushing bite of the bigger tyrannosaurs.
So maybe hunting different things,
That's the prevailing hypothesis. Maybe specializing in smaller, faster prey.
which would make sense if it lived alongside Tarbosaurus,
Well,
avoids direct competition.
exactly. Like predators sharing an environment today often specialize. One takes the big stuff, one takes the smaller, quicker stuff.
Those long, sort of delicate snouts in Alioramus and Chiantosaurus probably weren't suited for tackling really large, struggling animal.
Likely not. Not in the same way a Tarbosaurus could, even a young one. Though you have to consider, maybe the big guys sometimes preyed on the Alioramans.
Oh, interesting point. A predator-prey relationship there, too.
It's possible.
Yeah.
And biomechanical studies looking at skull stress during biting,
Uh-huh.
they indicate Alioramus likely experienced lower stress levels compared to the big tyrannosaurids, which, again, supports a different feeding style, maybe less force, more agility.
Okay, let's talk growth. How did these things develop? You mentioned the LA Altai specimen was young-ish.
Yeah, bone histology, looking at the bone microstructure, suggests it was about 9 years old when it died, and still growing.
But even at 9, it was relatively small compared to other tyrannosaurs at that age.
That's right, which hints that the adult size for Alioramus was probably genuinely smaller than its relatives.
And that slender build, the long snout, that wasn't just a juvenile feature that would bulk up later.
It seems less likely than in other tyrannosaurs, and those crests, well, cranial ornamentation often gets more elaborate with age in dinosaurs, so maybe adult Alioramus had even more impressive headgear. We don't know for sure.
And comparing Alioramus with Cantusaurus,
Yeah.
does that help figure out the growth stages?
It does seem to. The current thinking is that both Alioramus species are known from juveniles, maybe at slightly different points in development, and some researchers propose that Cantusaurus might actually be an adult Alioraman.
Ah, okay. So the differences we see could just be growth stages within that group.
It lines pretty well with growth trends we see in other tyrannosaurids, yeah.
So maybe Alioramans just didn't go through that huge shift from sleek juvenile to super robust adult.
Possibly. Maybe they stayed relatively gracile, better suited for chasing agile prey throughout their lives.
Interesting.
And there's one specific kind of technical growth feature they found in the cheekbone, the jugal. Rugo's process. Starts small and pointy in young ones, gets bigger and less distinct in older ones, another little clue to their development.
Right. So finally, the world Alioramus lived in, the Nemegt Formation, late Cretaceous, about 70 million years ago.
Yep, Maastrichtian stage. And the beds of Nogon Sav, where A. remotus was found, seem to be the same age.
And what was that environment like?
Wetter than earlier times in that region. More of a floodplain, rivers, soils, though still with some periodic droughts, it seems.
So quite lush, supporting a lot of life.
Definitely. A really diverse dinosaur fauna. You had Tarbosaurus there, the big predator.
Uh-huh.
Lots of ornithomimosaurs, the ostrich mimics, the rhizinosaurs, those weird ones with the giant claws, and even giant Titanosaurian sauropods.
Wow, so a pretty vibrant ecosystem for Alioramus to fit into.
Absolutely. A busy place.
Okay, so let's wrap this up. Alioramus. It really stands out as this distinct side branch of the Tyrannosaurs.
Yeah, slender, long snout, those cool crests, way more teeth. It all points to a different ecological role.
Probably not competing head-to-head with Tarbosaurus, maybe specializing in smaller, faster prey in those Mongolian floodplains.
That seems to be the most likely picture based on the evidence we have.
But like always in paleontology, there are still questions, right?
Oh, absolutely. Since our main specimens seem to be juveniles.
Yeah.
What did a fully grown adult Alioramus look like? How big did it get? Did the crests get even bigger or change shape?
And exactly where do the Alioramini fit on the family tree, and why do they only seem to be found in Asia so far?
All great questions. Still lots to discover.
Which leads to a final thought for you listening. If Alioramus shows this kind of unexpected adaptation within tyrannosaurs,
Mhm.
what other weird and wonderful tyrannosaur lineages might still be out there, undiscovered in other parts of the world? What else could they tell us about how these apex predators diversified right at the end of the age of dinosaurs?
Yeah, makes you wonder what's still buried, waiting to surprise us.